sNow, it's a cluster suite. So many of you probably have experience with previous cluster suites or software ecosystem that deals with node deployment, node configuration, and also integrates byte-scale systems and so on. sNow does that thing, but many more features are coming. So it's an open source cluster suite. It deploys, as we talked, but it also includes a monitoring system, cluster file system, templates for deploying cluster file system servers, and also includes the client side. And also many other stuff like the byte-scale systems, parallel and mathematical libraries. And this is pretty much what you have already integrated at this moment. We are talking about the management suite, which contains the deployment system, the cloning system, and in addition to that, central cluster management, which is based on CF engine. At this stage, we're thinking now to enable. And then you have the performance suite, which includes the machine libraries, and it also includes chain pointing capabilities at kernel level, to checkpoint applications move or restart in some other place, to achieve more performance or more allocations capacity. It's completely hardware agnostic, so you can deploy that thing on any x86-64 architecture. Only works on Linux, obviously. In addition to that, we support several batch queue systems and workload managers. At this stage, it's Grid Engine, Slurm, LSF, Jordi, malware, and also more. In regards to the cluster file system, we have templates that can deploy servers with Lustre, BCFS, Lustre file system, and also Ceph. In terms of security, which is a key point for sNow, it also integrates many security, proactive security elements on top of this, and in addition to that, active response. So if something is wrong there, if the system detects some intrusion, so it can react and it can set up something in the firewall or in the NTN to protect the whole setup. Because the system was born for mission critical environments, so we have a clear component in the hierarchy suite. So the most critical services have a hierarchy and at the same time load balancing. So this is pretty much the suite. And on top of this, we also use EasyBuild for building scientific applications. So as you probably know, EasyBuild is a tool that allows you to build the scientific applications in a revolutionary mode. And in addition to that, it creates all the user ecosystem that they use to interact with. So it means model system, all the environment variables that needs to be set up inside each model. And once you load the application model, it will also load all the dependencies. And if you want to build, I don't know, ROV, which is one of the well-known applications for weather forecasting and so on, it has around 10 different dependencies, pretty much. So it also downloads and compiles every single piece of code that also depends on the main one. So what is doing for deploying and cloning the system? So we deploy the system using native Linux distribution system. So for Debian and Debian-like, QuizFile, and for as well as auto install. for a Red Hat Kickstart and so on. So this is only for deploying. Once you have a system already deployed, one node, in order to propagate and clone the system, we use a system imager with a torrent layer. So this will allow you to clone the whole cluster in question of minutes. So it's just a deploy, you have the template, then you upload you merge that thing into the system imager system, and then you clone the system quite easily and quite quickly. In addition to that, if you want to change few parameters or a few configuration files that are key for managing the cluster, then it's a good thing to have a CF engine. We are using CF engine for roles. So we create different roles, and we are maintaining at this time 3 different ones, each one with a different Linux distributions. So we are maintaining a specific role for HPC, in addition to that, one for high throughput computing, and another one for big data. So it's a different setup, different needs, and that's why we set up different roles for it. So critical servers are isolated into VMs. So this is a key point as well for us now. The traditional way of driving HPC in small centers is to have a head node and then the compute nodes. But what is going on when the head node have some issue with, I don't know, LDAP, it's crazy and it took the whole memory of the system, or you have a DOS attack through the SSH and it took a lot of resources there. So if the head node is at the same time the cluster file system that also use the rest of the compute nodes, most probably, your cluster will suffer of that thing. If you have this kind of users that are used to run some kind of code in the head node, because it's the login node as well, so it may affect the whole cluster as well. So it's a key piece of hardware that you don't want to have major issues there. So the best way to minimize the risk is isolating these kind of services into VMs and segregating them by functions. So for example, we can create a monitor system, VM for monitoring, and allocate all the servers in a VM. So we have allocated into a very specific number of amount of memory and some CPUs and so on. And because we bought these VMs via NFS route, you can scale up. So you can put some of these machines into one compute node, and in addition to that, you can set up a hierarchy, a load balancing layer across many physical nodes. So, and as I said, for development and scientific software, we are using EasyBuild, which contains several hundreds of different applications and all its dependencies. And it makes the life easier for maintaining the scientific software. And at the same time, you can achieve a lot of performance because you build the applications on the nodes and on the architecture that you are actually running the code. So you can achieve to use all the instruction sets that you have in the hardware that you have in the data center. So HPC now have developed this tool, and it's because we focus on performance. Actually, we are talking about high performance computing. We don't want to lose this key part of the equation. So all the software that you are going to install, thanks to sNow, it's highly tuned to the architecture that you have and the hardware setup that you also have. So, for example, some other kind of distributions that you find in the open source market or in the non-open source market provides pre-built MPIs, pre-built OpenMPI that sometimes doesn't include the offer libraries, or doesn't include a tuned offer libraries that some vendors like Mellanox also provide. Okay, that kind of things that can easily be tuned is not there, and you lose some kind of performance if you are not using it. So it's an overhead every time you want to do that kind of things. So this is going to minimize the overhead that you need for the efforts that you have to apply in order to have to achieve the maximum performance in your system. And we designed that thing for a mission-critical environment, for that kind of environment that wants to achieve the minimum downtime. And in addition to that, in addition to the high availability and load balancing layers that we have, we provide the best practices to minimize the downtime. So something like, for example, rolling updates, or migration from production to pre-production to production. So it's sometimes you cannot run a full outage just for updating, I don't know, a release of the cluster file system or a release of a batch queue system. So you can spend a couple of days or 1 week. It depends on the workload. It depends on the user needs and the work and the jobs that are actually running in the system. But it can be done. It's just a matter of time. And also, it's designed for a large-scale system, and it's because of the scalability features that it also provides. It enhances the security and the privacy in HPC environments, including in the cloud. We're going to talk about that thing in the roadmap space, but since we also work into network segmentation, so it's easy to filter and know what is going on in each VLAN. So, so it's an open question that I would like to know more about from you. If you have this kind of features in your system, if you are actually segmenting the network that you are using for compute and segmenting for usage of this. And in addition to that, we have a proactive security on top of the DMZ services. So, well, in terms of time for production, this will also minimize the efforts. This also minimizes this kind of time that it usually took to move forward from the boxes that you have the hardware on to actually running jobs there. So usually when you have a new cluster, you only need to just plug a couple of cables in the network, sNow network, and it will automatically deploy and do all the stuff. More things. So usually to have a production cluster, it's what usually the small HPC centers have. But as you grow, you will discover that you need something to test. You cannot apply changes on the fly. You cannot merge changes that you have no test at least in a bigger scale. So that's why we create this kind of triple environment. So it's very common in large facilities. So it's a testing, it's a pre-production, and finally the production. And because all these things can be easily moved because RVMs, and finally what you have is a backend file system. You can move moon points from testing to pre-production, and after that from pre-production to production without no downtime. So probably you need a rolling update, it depends on the service, but probably you don't need even a rolling update. Just changing the IP address and in the configuration file, and if the timeout, it allows you to resist that thing. So there's no rolling update to be applied. Okay. So that's the main point. Is this now suitable for dummies? Okay, this is an honesty question. You will see in the market a lot of or in the open source community, some other cluster suites that promise you that with the right skills of click and double click, you will be able to run HPC facility. Okay. So the truth is that HPC requires some kind of needs, requires some kind of skills, and this kind of skills probably are not suitable for that kind of people that want click and double click. So you have some kind of facilities out there that allows you with a minimum skill set to run code there. But this is not the target user for sNow. So this is for mission critical, this is for performance, this is for security. You need something else. And we know that the community is asking for a graphic user interface. Yes, we have a graphic user interface with a product. Okay. We only develop at this stage command line interface. It's easy to understand. We are working in the documentation, and once we have a complete documentation for a final stage, we will publish the code. That's the tutor here. Okay. So how it works, how it behaves, that thing. At this stage, it relies on fault-tolerant cluster file system. We export from the file system that you have in the backend to NFS root. So all the VMs that you have in different physical nodes will boot these VMs through NFS. So this is a key point, and this is a key feature that allows us to scale out. Okay. So as you can see here, you have some examples of how many VMs you can have there. And it relies on Shen project, because it's really easy for us to put VMs through NFS root, and it also provides a lot of features that we really like to have. And for hierarchy, we use a different software setup. So we, from the system point of view, we use Herbie2, Pacemaker, and ColorSync. But at the same time, there are some applications or some kind of services that also provides a native load balancing and hierarchy. So we use, at the same time, that thing as well, when it's applicable. So, well, and in addition to that, you have a complex infrastructure in terms of layer 3 and layer 2 connectivity, to segment the system into different VLANs, and this is again for scalability. So network segmentation is key to avoid network contention, and in addition to that, it improves the security. So if we want to replicate that thing into the cloud, it's far easy for us to move stuff from here to the cloud, run code there, and then look the results. Okay. If you have a small system and you are not concerned about the security, and you want to minimize the effort in terms of network segmentation and so on, so you can remove this part of here and use just a single VLAN. Okay. So it's not a big drama. You don't need to rely on layer 3 network. But if you have a reasonable large system, you will need that thing anyway. Otherwise, you can face another kind of problems, and that's why by design it's trying to avoid all these problems as well. So, well, as I said, we have a very nice and beautiful command line interface, and we have the easy build integration. So we have a lot of engagement with University of Ghent and the community from EasyBuild. We are actually contributing back to the EasyBuild as well. We are using CF Engine as a configuration manager, because all the tests that we have done with Puppet and CF Engine is that it actually have a very small footprint in terms of memory and CPU consumption. So it's around megabytes and very low in terms of CPU usage. But so this is again something that we would like to have contributions from the community, and we want something that could be actually easy for all the people, to have more people contributing back to this project. So we know that CF Engine is quite complicated. It's not as complicated as many other stuff that you are actually doing, obviously. But it makes, compared to Ansible or Puppet, it's a little different, okay? So we are considering that thing. But one of the key points to use CF Engine is that it can roll back, it can self-kill the nodes that you are actually exposing to a DMZ. And this is proactively security. So about the roadmap. This is Tekapo Lake, New Zealand. So if you ask why, okay. The roadmap for this year looks like this. So first of all, we will try to encourage community to get involved in that thing, and that's why we are going to publish a dataset with all these features and this kind of information that you have in these slides. We are about to start to work with more, because we would like to offload some kind of works into the cloud, and MOA provides that thing, and it's really easy to do it. We are going to integrate an issue tracking system that will automatically create and generate issue tracking into generic provider, if you like. So hardware vendors, consulting companies like HPCNow or some other consulting companies that can provide that kind of support using sNow could also use that issue tracking for following the issues that you have in your data center. We are going to integrate data transfer network. It's already there. It's already integrated for some of the distributions that we are supporting, but not for all of them. So we are going to complete this this bit as well. We are working on the user guide. We have one new person in the team that will actually use her time to work in this regard. So the code will be available in the Bitbucket. So we decided to use Bitbucket because we can hide some kind of the code, to publish only the final stage one. So we are working as well in testing, and then in the production we are want to just publish the production one at this stage. And more things, OSEC and PF sense integration. So we would like to have OSEC integrated with the packet filter that PF sense also provides, and then apply some kind of rules there for all the DMZ service that we are exposing to internet. Another key feature is the cloud bursting that I'm going to talk about that thing in very few time, and also big data extensions and remote backup. So we believe that in very few time, ARM is going to be a key platform for HPC. And we like to advance this bit as well. So that's why we are going to start to work by the end of this year in porting all the software ecosystem that we are maintaining in x86-64 into ARM64. So as you probably know, Mont Blanc project, it's right there. So yesterday during the personal supercomputing visit, you were able to see the 2 racks of a Mont Blanc project there. So we are about to run actually real code there. And this is a requirement. that we know that the community is going to ask for. So it's a dashboard. We don't know yet which kind of tool we are going to use, but it's something that we have in mind. Okay. So regarding to the cloud bursting, so we are working in native cloud bursting, and this for this reason we are looking at solutions like Advenia in collaboration with Green Cloud is providing. It's hard to find some kind of cloud providers that are sensitive regarding to HPC. And when I talk about sensitive, means that we actually want bare metal, but at the same time we don't want something in between that can potentially expose the file system from other people running the same code there. So it's talking about the security issues, we are talking about privacy and so on. So that's why we are looking at this kind of facilities, and in addition to that, actually HPC facilities, because they understand very well the needs of the HPC community as well. So what we are looking at is infrastructure as a service, in order to avoid these performance issues and improve the privacy control. And the idea that we have in mind is to develop some plugins. It depends on the Blasco system. This is going to be, at this point, Blasco system dependent. Okay, but we are about to finalize some kind of a code plugin for Slurm for budget-aware scheduling. So this means that if you have actually something running in the cloud, and you have a local facility that was running out of space, and you have to offload that thing into the cloud, but then you have some slots that could allocate this kind of jobs that you have running in the cloud. And if these jobs are checkpointable, well, we could migrate. We can generate a checkpoint there, move the state file, or move the small information that will require to migrate back the jobs into the local facility, and then continue that thing running in your local facility, avoiding this way to pay an extra bill in terms of cloud provider infrastructure. Okay, so you don't need to burn extra compute hours if you have a local facility there. So for big data and high performance data analytics, we are going to integrate that thing by the third quarter of 2015. So some of them are already there, but we want to provide a complete data analytics stack. Okay. So how to contribute to this project? So how to get involved in this project? Well, the first thing is that we want feedback. We would like to have some HPC facility testing that thing. We have already installed sNow in several places right now. So it's already installed in the University of Barcelona, in CSIC, in University of Girona, Pompeu Fabra, and some other places that I don't remember right now. But yeah, it's already in production. But what we want is having feedback from people that understands well what they are doing, and receive back this kind of feedback, in order to improve the code, in order to improve the services and the software stack as well.